So, good morning again. Welcome to our workshop. I hope it will be enjoyable and useful as well. And feel free to make any questions you need anytime. You can interrupt me. No offense taken. Except for Maria. Maria is not allowed to make any questions. No, everyone else is more than welcome. Okay. If you don't understand anything, or if I'm talking too quickly, or my accent is not very understandable, please stop me and I will try to correct that. Okay, so hands on ancient Greece. As you know, eTwinning is very it's very, you're just... it's very keen on experiential learning, on hands-on activities, on engaging students and teachers in meaningful activities. So we have tried to put on a workshop that deals with some things related to Pylos and to ancient Greece that could translate into eTwinning activities. So, first of all, a few words about me. I am a language, literature and history teacher. I teach in Thessaloniki. It's situated in the northern part of Greece. I don't know if any of you has, I know that some of you come from Thessaloniki, but I don't know if the others have already visited, or you are more than welcome to visit northern part of Greece as well. Not that scenic as Pylos and Messinia here, but you'll find plenty of beautiful things to do there as well. So, I teach language, literature, and the main part of the workshop has to do with history and language. First of all, let's break the ice. Have you already connected to the internet? Okay, so you can scan the QR code. Here it is. We have already some people answering, at least one of you. Or you can go to slido.com and put the number if you are not. Okay, never felt better. Some of you are tired, but looking forward to the workshop. Great. No one has seen better times. That's hopeful. And why am I even here? Okay. If you select your answer, you need to push the button, the submit button. Yeah. You're all okay. The internet connection might be a bit slow. Yeah, we'll wait. We have plenty of time, don't worry. And what's the first thing that pops into your mind when you think of ancient Greece? I guess that some of you have already some stereotypes about ancient Greece in your mind, or you have visited, or you have already visited Greece, and you have some vivid images of Greece that you can share with us, everything. Myths, great. And actually we are in a place, Pylos, that is referred to, many of the myths refer to the Trojan War. History, Greek philosophy, ruins, monuments, magical history, great civilization. Everything is great and mythical here in Greece. You can live your myth in Greece. Greek gods, yeah. Great civilization. Maria, why are you laughing? With me or at me? Yeah. I thought you said that I am a Greek god in person here delivering the workshop. Minotaurus? No, I'm not Minotaurus. Okay, great. We have and rank the following ancient contributions according to their importance, starting from the one you consider to be the most important one. theater, democracy, Western philosophy, and Olympics. Just Western philosophy because ancient philosophy is not just an ancient Greek thing. There was the Chinese philosophy and the Eastern philosophies, just to have a perspective. Okay, but democracy seems to be the most appreciated contribution of the ancient Greek civilization. Then philosophy and theater, and the Olympics rank low in the scale. Okay, so you're all democratic people. That's hopeful for the world. You talked about civilization, history, myths, a great history and achievements of the past. You can see here a picture of one of the main achievements of the ancient Greek civilization. It's one of the very first writing systems, and you already heard some things about it yesterday from Mr. Angelopoulos. It's the linear B writing system used by the Messinians in the late Bronze Age. You can see we are in the 1400 to 1200 before Christ. And it's one of the unique writing systems, and you will find out why in a bit. Actually, here in Pylos, there have been found a lot of tablets like this one. Not the tablets we use nowadays, the ancient ones. And not only in Pylos, but in other places in Greece as well. You can see that in the northern part of Greece, there have been more tablets found because the center of the Messinian civilization was in the northern part. Peloponnese and Crete were the main areas where the Messinians flourished. And Pylos, we are somewhere here, was one of the places where more than 1,000 tablets were found, and while excavating the sites here. And the main reason that they survived, these tablets, was they were made of clay, but clay won't last. But due to a fire, they were baked. So this is the reason they survived till nowadays. It might be a disaster at the time, but for us it was a fortunate event because it helped us find the writings of these civilizations. As you probably have heard, the distinction between history and prehistory is defined by the use of writing. So to find a writing system of the area is of a crucial point, and the other crucial point is to be able to read these tablets because they are written in a writing system that it is not being used nowadays. So the problem was to decipher these tablets. As you can see, it's not very easy, but the very interesting thing, for me it is very touching, that they used to make lines for the symbols to be in the correct order, just like the notebooks we use nowadays. You can find tablets like this in most archaeological museums in Greece, the National Archaeological Museum in Athens, and almost in every archaeological museum you'll find one or two of these tablets. They are in many shapes. The leaf-shaped are the vertical one, the horizontal ones, and the page-shaped ones are the vertical ones. And Maria is very fond of the vertical videos and tablets as well. Maria, you'll be my favorite. Yeah. And you can see a close-up of a tablet of clay, and you can understand why it is called linear. Because most of the symbols consist of simple lines. So they were undeciphered until 1952. Then Michael Ventris deciphered linear B for the first time. He was able to read the tablets, and it was proved that it is a Greek language. Now, as for the name linear B, why B and not A? Because there is another linear writing system which is called linear A, used mainly in Crete, but this has not been yet deciphered. We are almost sure that it is not a Greek language depicted on the linear A. It probably is the language of the natives that preceded the Greek people who came afterwards, and Messinians, but we have not been able to read them yet. So there are words like Gerousia and demos, people and council, and wanax, anax, anaktoro for the Greek ones, which means king, like, and we were not impressed by the texts that were read in on the tablets, because what do you imagine that were writing on the tablets? What was the content of the texts that were deciphered? Myths, history, just economical details. It's mainly catalogs of the products stored in the king's warehouses, storehouses. So it's words like oil, I don't know, oranges, water, wine, like this. So, how to write in linear B, and we are coming to the hands-on part of the workshop. The linear B writing system includes two kinds of signs. Most of them are syllabograms. Now, both the Latin and the Greek alphabet, they are not syllabograms. They are each letter corresponds to a sound. While syllabograms, each letter, each sign corresponds to a syllable. So there are many more signs than the alphabet we use nowadays. And there are also some ideograms which correspond to whole notions, to whole words, like male or female, just like the Chinese or the Egyptian hieroglyphs. You can see here the syllabograms that we found and we read on the tablets. Every sign represents an open syllable, which means open because it only ends in vowels, not in consonants. So you can see that we have ka, ke, ki, ko, ku, ma, me, mi, mo, mu. Each consonant with the correspondent vowel. The final consonants are never written on the tablets. Two adjacent consonants are either written with a dummy vowel, which means that if we have pt, pt, we'll see, and then an a, it will be written pata. It will take, the vowel will be used for both consonants that precede it. You will have an opportunity to exercise just in a minute, and we'll see what problems arise. And H is not usually written. As you can see, there is no sign for H. There are around 72 syllabograms used in linear B. And these are the ideograms. These are selected ones, like woman, man, sheep, horse, olive oil, wheat, textile, bronze, sword, and chariot. And you can see the numerals. A vertical line is 1, a horizontal line is 10, a circle is 100, and the circle with the cross is 1000. So, if you put the signs together, you will find the number that you want. This is a map of the area, and the name of the places are written in linear B. Can you find Pylos? Like the red one, exactly. This is why I put it in red, because it would be difficult to find it. But it says Puro and not Pylos. Why? L is not depicted. Instead of L, they use the same sign as for R. You remember that the last consonants are never written. So Pylos, the S, will not be written. U is the corresponding to epsilon, to I, let's say. So puro is Pylos. These were supposed to be syllabograms, but they are not recognized by the system here. Do you know who he is? It was his name in linear B. It was Agamemnon, yeah. But they are not written here. And now let's do some work. You will work in pairs. I think you are seated in pairs, so you can work. But please don't work with another Greek or a person of your own country, just in order to be mixed and mingled, and just from a person from another country. I will give to both of you. And I will give you instructions as well as you are. Η Κύπρος και η Ελλάδα είναι δύο διαφορετικές χώρες, δεν μας πειράζει. Να μην είναι όλο οι Έλληνες και... Θες και εσύ, As you can see, you have then the outline of several tablets. They are all leaf-shaped. And you will try to write in linear B. What I want you to write? The name, your names, both of your names. You will I'll teach you how to do that. And a number of whatever objects you like. So we need name, number, and an object. Your names will be written in syllabograms. I will give you the code. The numbers, you remember, I will give you the numbers and the corresponding symbols. And for the objects, you can either use the ideograms that you will find on the page, or invent a new symbol, a new ideogram for this object you would like to depict on the tablet. It could be something of the modern civilization, something related to STEM, something related to eTwinning, or anything. So it will be a new ideogram that will be added to the catalog of ideograms of the linear B. I will give you a page with the syllabograms that will be used for your names, and I'll tell you how you will do that, and the ideograms and the numbers, okay? Divide your name into syllables. For example, if we have the name Agamemnon or Helen, which is easier, Helen. Just the number of syllables corresponding to your name. You will use the grid I gave you to work out what sign to use for each syllable. Note that if a syllable or word has a final consonant, you won't use this consonant. You will have to use R's for L's, as you remember in Pylos, puro. So if your name has an L, you won't find any signs with la, le, lo, lu. You will need to use the R symbol. If you have an H, it won't be written. It will be as if we have a vowel on its own with no consonant in front of it. So if you had Helen, it will be like E. Of course, some signs can stand for several different values. You will see that the same sign might be used for two different syllables. If it gets too complicated, like Agamemnon, which we have two consonants, you can use the next vowel, so no. If you have two consequent consonants, you can use the next vowel for both of these consonants. I will be helping you out. So if you have kono, kno, you will use kono. Okay. If you can't find a sign corresponding to a particular sign, your name, choose one that sounds most closely to your syllable. Of course, there's no correct answer. Your names probably didn't exist during the Messinian era. It's just to play around with the linear B. And then for the numerals, you will use the signs of the numerals, and you either choose one of the selected ideograms or invent one of your own for a modern object. You have 10 minutes. I will give you some colored markers so that you can make your tablets colorful and... Πώς ανοίγει αυτό το ρημάδι όμως? You will be the first one to choose color, Maria. Όχι, θα σου δώσω εσένα κοκκινάκι, τι θες.
Αυτό θα το κάνω τα σχηματάκια.
Ναι. Ωραία. Τώρα θα έρθω, περίμενα. You want any colored markers to... Okay. I will give you some colored markers to make them... Τώρα, περίμενα να δώσουμε... και μετά αριθμό μαζί με ένα... Τον αριθμό θα τον πάρουμε από εδώ.
Ναι, αλλά ποιον αριθμό?
Ό,τι θέλετε. Ναι, ναι. Ακριβώς. Είτε από αυτά, είτε θα φτιάξετε ένα καινούριο. Maria. Okay, this one is for Maria, definitely.
What's that?
Michalis, this is for you. Natalia. Now I will... Natalia, this is for you. Let me... Oh, great. So we have a sticker. Okay.
Get a reward.
Yeah, of course you'll get a reward. And an ancient Greek themed reward.
Nice stickers, you tell me.
Yeah.
Thank you.
Does it have to be an object? Can it be an idea, for example?
Yeah.
Collaboration.
Sure. Very nice one. Great.
Oh, great, thank you.
And a sticker for you as well. And let me... Ooh. Ah, great. I love that. So you have your stickers as well. And here, the sticker, and for...
You want to write the name of the word as well?
I think we will try to
Find
to yes. Everyone has a sticker? No? You don't have the sticker? Wow.
I'm going to cry.
No, crying in my class. So, now that you have... Okay, Barbara, you're a step ahead. That's what I was going to ask you. You're one step ahead. I was going to ask you to take a photo of your... Now, have you already finished? Are we all finished? Okay. While you finish with your ideograms, you can take a picture of your tablets. First of all, to have a souvenir of the moment. And then you will upload it on a Padlet. There is the QR code for the Padlet here. Or if you need the address, there is a bit.ly shortened link that you can use. You will find a Padlet wall with 3 different columns, and you will use the first one, the linear B tablets, not A tablets, it was corrected, to upload your picture. You know how to do that? You press the plus button and this opens, and if you use the camera, the button, linear, yeah, it should be B, but it says linear A. I think that you should not write anything, and we'll see them and try to guess the name of the others and the object that you have created. If you have already written your name or the word, that's not a problem. It's just for the fun of the activity, but so if you upload it with no name at all, we will try to guess whose name is and what the ideogram represents. In the first column, yeah, the linear A. We should have been linear B, but... So, can you guess who responsible cockatoo is? Use your grids to decipher who responsible cockatoo is. One of us is responsible cockatoo. And who is the responsible cockatoo? Try to decipher. This is the first tablet, is his or her name. If he or she has done a relatively good job, you will be able to decipher his or her name. Come on, people. The first letter is easy. A. The second is R. Adonis. Yes, great. So Adonis is the responsible cockatoo. Okay. And what's the object that Adonis, aka the responsible cockatoo, has come up with? The last one. Forest? Yes. Great. So you can see here the link to the computational thinking, to the decipherment. You see that we can use a language activity that has to do with a writing system in order to enhance critical thinking, creative thinking, out-of-the-box thinking of our students. Let's see. Now we have the name. So we'll try to find the object. Boat. I think that there is a sign here. It's boat? It's a sailing boat. A sailing boat, exactly, yeah. So this is the little details that make the proper sign. Next one. Okay. Who is this? Grandma Katerina, you are.
We know the people.
You are. Yeah, but.
We know the name, so if you find
The first, exactly. You are the linear B expert here at the workshop. And we have a new object, a new ideogram that Maria has come up with.
A cell phone?
A cell phone, yeah. So a couple of more examples so that we move on to the next activity. And yeah, summer, definitely. ice creams, sun, and Greek summer, I would say. That's the eTwinning pen and pen, yeah. Can you see the object? Computer, yeah, laptop, I think isn't it? But maybe we should. Someone used the pen to conceal the name, I guess. That was tricky. What's the first letter?
Invisible something.
Okay, I think I know who it is. Erwin, yeah. Katerina, you are golden star. And the last one, I guess. Oh, yeah. Somebody had the same idea. But I love the ideogram at the end. Yeah. Let's find, first of all, who. Katarina, we are all depending on you. Here, let's find who the person is first. Marriage. Anyone named marriage here? It's Katerina? No, I think it's not Katerina. It starts with a K, but it might not be K or. Yeah? It's Carmen. Yeah, great. And as you can see, I love the ideogram. It's not marriage, it's eTwinning. Collaboration, the stars, a pencil. It's the eTwinning in the ideogram. I think that this should be shared with the CSS. eTwinning in linear B. Who would have thought? I think we have another couple of eTwinning ones, if we find some. Okay, the internet connection is not very helpful. So, let's skip that part. Are we okay with the linear B? Yes. Okay. Yes. But let's see, since we are in eTwinning contact seminar, just not an ancient Greece themed seminar, how could this activity be translated into an activity that would fit into an eTwinning project? Any ideas? How could you use this activity as part of an eTwinning project?
A message to another school, a secret message that we don't want to know.
Of course. Messages that were exchanged by people, by pupils, encrypted in linear B.
The ice-breaking activity, what we do at the beginning of the project, could be in the idea of that symbolic
Exactly.
presentation. So
It would be a great starting activity in order for the ice breaking to happen, and
also for Code Week.
for Code Week, exactly. Exactly, and this is the link to STEM here. Great. And you can even have students collaborate in writing a text in linear B, or even a story in linear B that one pupil from one country starts and the students from another country continue, and so on.
It would be a change story based with symbols.
Exactly.
And then we would have different teams in schools.
Exactly.
Decipher. So
Exactly. Exactly. That's the way of thinking eTwinning wise. Exactly. And so this could be translated into many activities throughout the project. Okay? Great. Do we have anything? Oh, this one? Can you guess I know. Family? Oh, it could be, but it's not, I think. Team, that's very close to team. Teamwork, very, very close. Collaboration, exactly, that's collaboration in ideogram. Dance, yeah, of course. Sirtaki. That would be a hands-on activity to teach Sirtaki here. Great. So let's move back to. Let's talk about ancient maths. We have time. As you know, a lot of the well-known, famous mathematicians are ancient Greeks. Even now, we use the geometry that Euclid invented, although there have been a lot of achievements in mathematics since the ancient Greece. But the foundations and the way of thinking, it's 10 o'clock, isn't it? We have 1 hour and a half still. Okay, I thought that I needed to hurry. Okay, because Maria is looking me. The rest of the workshop. I'll surprise you. Let's see. Ancient maths. They made a lot of mathematical advancements. So it was not just language and literature and architecture and art. It was science and maths and physics and so on. One of the very famous mathematicians of the ancient era was Thales. And he used a very original and creative way to try and measure the height of the pyramid. Does anyone know how did he do it? Because as you can imagine, it was not very easy with the equipment and the technology they had at the era to measure the height of the pyramid. The shadows. And he used the ratio to see when the ratio was 1:1 for his shadow, it would be 1:1 for the shadow of the pyramid. But this would be done only in a specific time from the day, exactly. So this was his way of thinking out of the box and trying to find a way to measure the height of the pyramid in a way that could not be done otherwise with the equipment of the era. And here is a very famous theorem that tortures students all around the world. I'm sure that all of you have heard of the Pythagorean theorem. And it says that the addition of the square of the legs of of a triangle that is 90 degrees equals to the square of the hypotenuse. If I pronounce it correctly. Hypotenuse? Exactly, in Greek. So, here is Pythagoras in an AI created picture. And if you want to chat with him, you can scan the QR code. If you want to meet him and ask guidance for your lessons with your students. He is quite helpful, I hear. You can put any name you want if you want to chat with him. If he asks for one, you are not obliged to put your real name. And feel free to ask him whatever you want. Now, we are a lot of people interacting with the same chatbot, so it might be a little delay, some delays, but let's hope that you will find a way to chat with Pythagoras. I have already told him who the audience is.
Yeah, because when we called him, the answer was
Yeah.
so we didn't have to.
You can keep touching. Exactly.
What is the full address?
I will show you. Humi. Yeah.
Also, I'm using another one.
Mizu. You're using Mizu? Which one? I will show you a couple of them, but you can share yours as well. Δεν θες να μιλήσεις με τον Pythagoras εσύ?
Ναι, φορτώνεται.
Maria, are you chatting with him?
No, chatting
Everything okay? Working? The chat is working? Great. So chat with him for a couple of minutes more if you want, and then we'll move on. It was just for to explore the possibilities of AI. So as you can see, the artificial intelligence provides us with new opportunities for teaching, for using different tools that students can interact with, and they can learn not from us, but straight from Pythagoras. Imagine Pythagoras teaching the Pythagorean theorem to the students, which is kind of, yeah. It's a bit scary. It might be a bit scary, but it is very engaging and fancy. Yeah. So, if the chat didn't work, I had some screenshots here in case something went wrong, but everything went well. So, chatbots. As you already know, chatbots are computer programs that simulate a human conversation. We have all been there. We have chatted with airline chatbots, with internet provider chatbots, with telephone companies, providers chatbots. It's the new trend, and it's been used more and more in education nowadays. I will show you two tools that you can use to create a chatbot for your students. The first one is Mizu. You can find the link here, and there's a QR code if you want to scan and go to the first page, the home page of the tool. There is a possibility to create an AI-generated chat. So you just ask the tool to create a chatbot for your students, and Pythagoras will be guiding them through the process. Or you can customize the chatbot yourself, giving the necessary details. I will show you in a moment. You can put a title, you can give some instructions, the grade level, the picture, and the name of the person. And then you can put a welcome message, rules, and if you pay only in the paid version, you can upload a knowledge file, which means that you can use a PDF or a document where all the information that the chatbot uses come from this file and only. If you don't want it to take information from all different sources. If you want to control the sources that the children interact with. But this is only in the paid version. And the one you tried now, the one that we used to chat with Pythagoras, is History Hello, or Humi, as you can see. It's for teachers and schools. There is a free version, but with very limited functionalities. There is the paid version, which is around $14 per month, I believe, and that gives you a lot more tools. Hello History by Humi. Humi, yeah. H-U-M-Y. And this is a tool that has already some chatbots created for distinguished people of history, of science, of literature. You will find a lot of already made lists. This is the tool, yeah. You can find the QR code as well if you want. It's humi.ai. There's a free trial period of a couple of weeks, so you can give it a try if you want, before you decide whether it is useful for you or not.
It's not free.
There is a free version, but with very limited functions. There are some collections of chatbots about classical civilizations, about Greek gods, cultural icons, even fictional literary characters from all kinds of countries and history periods. But the ones that are related to ancient Greece are the classical civilizations and the Greek gods. So, yeah.
A suggestion about finding new chatbots on the Teams is asking a chatbot, ChatGPT,
Exactly.
what can I do? How can I find more chatbots on Greek gods and culture,
Yeah.
whatever? And then thousands of things appear.
Exactly.
New
Everything
ideas.
is interconnected right nowadays. So you can go from one tool to another. Yeah. Great. So there is a free trial version, and this is per year, the $130, but you can choose the per month option and just pay for 1 month, and then cancel your subscription. So we talked about Thales, we talked about Euclid, about Pythagoras. Here's Euclid. This is an actual papyrus fragment of Euclid's Elements. This is one of the most well-known maths works in the history of mathematics. Στοιχεία is called in Greek. Elements, where the basic geometry terms and theorems are written down. And now, since we talked about geometry, let's work with scale to produce a drawing. The second hands-on activity of our workshop. What is scale? I hope you all know what a scale is. You're familiar with. But most students are, during their primary years, learn how to use the scale, and especially on a map. Because all maps are created in a scale. If we were to create a map full size, it would need the size of the whole Earth. In order to create something more useful and in handy, we use a scale, which is ratio. You remember what we talked about Thales and ratio? The notion of ratio was a very important notion for ancient Greeks. You know, you have heard about the golden ratio, the perfect analogy of the Parthenon architectural elements arranged in the perfect way to look great from a distance. And another use of ratio is to create drawings and maps and in scale, which means every centimeter on the paper corresponds to a different measure in the real world. It might be a meter, a kilometer, or anything else. We use it not only in maps, but in house drawings as well, for the architectures to communicate with the engineers, where the door should be put and the windows, etc., etc. Here you can see an example. This is a map of a country. I don't remember which country is. Georgia, something like that. I'm not sure. There's a cross. And you can see it in a 10 centimeters and in a 5 centimeters scale. 2 centimeters in the big drawing corresponds to 1 centimeter in the smaller one. And this is the plan of Maisie's bedroom, drawn with sizes in meter. But we could create this to a smaller scale. Well, 1 centimeter in our drawing corresponds to 50 centimeters in real life. I won't put you to do this, but you will measure our classroom. You will create the drawing of the classroom. you will need to measure the walls. You will have this kind of paper that you can use, and you will have a small ruler to create the drawing. Ah, okay. So the first thing is how you can measure the walls.
Step by step.
You can do it with steps, or there are apps, mobile apps that you can use. If you have one, or if you are willing to download one, or I can use mine to help you with. If you have an iPhone, there is an already installed application on your mobile phone. I will tell you exactly right now. It's called Measure. And if you have seen, you point to a certain point of the classroom. You create a point there. Move closer, yeah. And draw a line to the other. And it says that it's 5 meters, almost, 523. And you can take a picture of this and then go to your... And as soon as you create your drawing, you can upload it at the same Padlet, but on the second column. Okay. How's everything going here? Great? Okay. You can... Approximately, of course.
We did it very small, I think.
But no, that's not a problem. As long as you indicate the scale, the ratio that you use.
1 meter is 1
Great. And you can even try to put approximately the door or the windows if you want. Approximately. But just indicate the ratio. The important thing here is to indicate the ratio so that the others can translate into the real world. So, another activity that could be inspired by ancient Greek science has to do with Archimedes. Have you heard of Archimedes? There is a phrase of him that is very well known around the world, Eureka. And the activity here has to do with this Eureka moment of Archimedes. This has to do with physics and the density of materials. And Archimedes was a very well-known scientist of the ancient era. He was known as a very clever guy who could find solutions to difficult problems. And he lived in Syracuse in Sicily, which used to be populated by Greeks. And the king of Syracuse had a crown, and he was not sure that the crown was made of gold. They assured him that it was made of gold, but he couldn't be sure himself. So he asked Archimedes to help him to find out whether the crown is actually made of gold or not. And Archimedes decided to have a bath to think about the problem and find a solution, and the basin was full, and as soon as he entered the bath, an amount of water came out. So this gave him an idea for how to work out if the crown was actually made of gold or not. And he was so excited that he found the solution, and the legend has it that he jumped out of the bath and said, "Eureka," which means, "I have found it," in ancient Greek. And he was naked, the legend has it, while he did that. And he rushed out at the streets to go to the king and announce his achievement naked and shouting "Eureka," which was not a very wise thing to do. Do not try this at home.
Or at school.
Or at school, yeah, even worse. So his idea was that the the volume of water that is displaced when an object enters water is proportional to its density. So you can have an idea about the density of the material depending on the volume of water that is displaced. And all materials have different densities. So if you can define the density of gold, you can then find whether the crown was made out of gold or not. So if two things are the same size, the one that is more dense is heavier. It has high density, as it would mean. And density can be calculated if you divide the mass with the volume. So we could create, we won't do that, don't be afraid. If we had the time and the equipment, we could go for that, but we would need water and different materials and
get undressed.
yeah, and shout Eureka in the streets of Pylos, which might cause a bit of mayhem here. But you could use materials of the same size. You can urge your students to use materials of the same size and weigh the material and write down the weight in grams, and then place the materials on a tray and a bowl, which is put on a tray, and the bowl will be filled to the brim with water, and put the object in the water, and the tray will catch all the water that overflows, and then measure the water and write down the findings, and then work out the density of the different materials and review the results. You can have different teams, groups working on the same measurements, and then compare the results and see whether they have found the same things, etc., etc. So, what other activities can you suggest that could be inspired by ancient Greek, mathematics, or science, or anything else? Can you come up with anything, or?
Another object.
Oh, yeah, of course.
3V, but I don't know how.
Friction, I think it is in English, if I'm not. Can you have any ideas that how could?
Okay, but this is an activity for kindergarten children.
Okay, great.
We can use mini cars, the toy cars that we have in kindergarten, and make races.
Yeah.
In
Different kinds of.
yes, Leo, Trachil, I don't know.
Yeah. Whether it is a harsh or a steel.
Yes. After these experiments, we can have some.
Conclusions.
Yes, about the material, the way
Yeah.
that the little car go on.
Exactly. Yeah. Then how it affects the speed of the.
3V in kindergarten.
Exactly. Great. Any other ideas? It could. It doesn't need to have to do with physics or chemistry. It can do with anything.
I don't know the word,
Trabala.
trabala.
Seesaw. Yes.
How we can fix up a heavy kit
Ah, okay. With.
easier, and where we should put
The way in order to balance the.
how children with low weight
Yeah.
can high up heavier children.
Ah, okay.
More easier.
Easier. Oh,
And
I would like to hear about that.
we have to move the axons,
The axis.
the axis, from
Closer to the the lighter. Yeah. Closer to the child with the who is thinner,
Yes.
in order to be able to lift the heavy one. Okay,
It's
great.
Archimedes,
Yeah, 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 yeah. Yeah. Oh, great ideas. And the next question is how these activities could be implemented, incorporated into eTwinning projects. First of all, could they? Could we have an eTwinning project based on such activities?
We can do it
And how could this be in a collaborative? Oh, exactly.
online meeting.
Yeah,
We can divide the children
in breakout sessions.
and after that we can make the experiments and announce in all children the conclusion of the experiment.
Great.
Easy way, but we don't have we can have a lot of students because
Yeah, yeah, of course, of course.
small groups.
confusing.
Yeah, like the activity here with the drawing and the scale drawing. Could we translate that into
Yeah, I think it's a
Carmen?
good idea because you can choose one of important monument of one country.
Great, that's my,
Change the
that was my thinking, yeah.
but before drawing the scale, you can investigate about the story of this monument. The students can explain this important monument, and then after that, they have to draw the pictures and put in a wall.
Exactly.
I think it's a really easy idea.
Yeah, yeah, and it could be collaborative and done in an exchange, and yeah. So we could learn a lot of things through the same activity. It could be an interdisciplinary activity because you have maths, you can have history, you can have language, you can have everything. This is our way of thinking. Great. And this is actually the main point of this contact seminar and of these workshops, is to find ways to be inspired both by ancient Greece and by STEM in our eTwinning projects.
And we could make a bit of, let's say, exhibition or a gallery where
Exactly.
students will
Exhibit.
project all these things.
Exactly.
And it would be great.
Yeah. So I hope that so far we have given you some ideas about ways that ancient Greece could inspire us for STEM related eTwinning projects. Okay? Now, for the final task of you, and then if we have time left, I will leave you to relax because you have done an excellent work, everyone here. If you go to the Padlet, you will see that there is a third column there. We will use AI again, but this time in order to create a drawing, a picture, an image. I don't know, of course you're familiar with Padlet. I don't know if you're familiar with the AI facilitated functions of Padlet, because if you press the plus button and then you press the plus 12 or what it is, you'll see that there is an option which says I can draw or draw with AI, something like that. Yeah. AI image. Something like that. It's different in your... If you press that option, you can give a prompt, you can give a description of the pic of the photo that you would like the AI to create. Yeah, the AI image, yeah. And if you... I would ask you to think of something related to STEM, to ancient Greece, to eTwinning, whatever, and create a prompt that would give you an image that could be I will tell you at the end what was my intention of giving you this task. Whatever. It doesn't matter what the quality of the picture, just to give you a way of thinking how this kind of images could be used in an eTwinning project. And then we'll discuss how this kind of activity could... What's happening next door? Yeah, and you will be next. It seems you are having a great time here. Mine are jealous. Yeah, they're enjoying the other workshop, so you will be the lucky ones next.
I didn't understand what kind of image we have to create.
An image that, any image right now, but it could be related to eTwinning or ancient Greece or STEM or anything.
Okay, thanks.
So, we have already some STEM activities, pictures for primary school or kindergarten. Is it kindergarten or primary? Yeah, I guess. Oh, we have here ancient scientists. Wow, I like this one.
Yeah,
Very nice. And it looks like Picasso as well, isn't it? Doesn't it look like Picasso? Yeah. So if we use more refined AI tools, we can even ask for a style, the painting style, and be inspired even by different artists.
Yes.
And so from STEM, go to STEAM and put arts in the picture as well. Children in ancient Greece play with geometric shapes. Great. Okay, so we have another one. Just wait for it to be oh, wow. Oh, and they have a lot of the geometric shapes, I guess, are tangram, yeah. And they are working with them. Yeah, you could use tangram with such activities. Oh, it's a school, it's an ancient school, and you can see the stereotype that everything that has to do with Greece is always put on an island with, with sea and sunshine, and even students. And you can see that the school here is very different to the one that we are situated in right now, but that's a very nice picture. Is anybody working still on his or her picture? Are we waiting for one, or? Ah, okay. No worries. I think I can move them.
Yeah, I'm trying to do it from here.
The labyrinth of Knossos. Yeah, of course. You could be inspired by the labyrinth and create even a scale drawing of the labyrinth of Knossos. And have you been to Knossos? Has anyone been to Knossos? Yeah. Crete, in Crete. Yeah. And the myth of labyrinth probably has to do with the very big and very complicated way that the palace was built. It's like the actual palace is a quite big building with a lot of buildings from here and there. You find yourself lost in the sense. So the myth of labyrinth probably resonates the sense that the people had when they visited the palace. So it could be created. Let me see if I can. Transfer. I will do it then. I will do it after, so as not to lose it. Yeah. We have another one here. 20 years of, oh, I love this. Pylos. Oh, yeah.
This one?
Yeah. Did you create it right now?
No, because I created one before.
Yeah.
And then it was lost and it couldn't scan, so I created it by chat.
Oh, okay. You can upload that as well. So, how could this activity be integrated into an eTwinning project? With what could this activity have to do with? How could we use AI images in an eTwinning project?
To make a story.
To make a story, great.
We have the words, the text of the story.
Yeah.
We can create.
To illustrate a story, or the other way around. To create the images and based on the images create a story. Or even we can have groups working with images and groups working with words and vice versa. Other ideas? We might be at the end of the workshop, but this could be at the beginning of the project when we are searching for the logo of the project or the project image. And we could have a competition and different students or groups of students create different AI images inspired by the theme of the project, of the subject or the topic, and then vote on which we could use.
We have used Leonardo
Yeah.
outline meetings that we had with children for another kindergarten from Poland. And after the meeting, we created a card with greetings. It was Christmas. The children spoke and said love, greetings, hello, and with this word we made a picture, the picture of our meeting.
Great. Great ideas. As you can see, we have ideas about ice-breaking activities, about project logo creation activities, about activities that promote interaction and engagement and collaboration between transnational groups. All of these elements that make up for a quality eTwinning project. And we hope that you create tomorrow your own projects inspired by ancient Greece and STEM. And you can even use some of these ideas for your project planning that you will need to create tomorrow. Don't forget, I'll remind you that you need to find partners for tomorrow project planning. And Maria is not here, but she will be the strict one who will guide you through the process. Do you have any questions about any of the activities that we did today? Any things that you want to clear out or anything that was... Okay. So, I think we can reach the end, and before that, let me... You can find me on all social media, or you can scan this Linktree QR code where you can find my social account handles and my email. And if you need anything, you can contact me. You can even find me on ESEP, on the platform, and we can be friends there. And I hope that it was a useful and enjoyable session for all of you. And before that, we can have a selfie, a group selfie. Hello. So we got it. I will upload it as well. Maybe I will put it on the Padlet. Thank you all.
have a kit of microbit. So, can we have microbit and a cable? Find it. This is microbit and a wire. So you connect in that way. No, no, for the moment. After. Yes, yes. Λοιπόν, έχουμε το microbit και το καλώδιο με αυτόν τον τρόπο. Σε αυτή τη θύρα, γιατί έχει και άλλη. This port. Microbit is a cheap kit robotics. Είναι φτηνό. Στην Ελλάδα έχει γύρω στα 25 ευρώ, 25 euros. Εντάξει, το έχουμε. So far, so good. Okay. Well, we begin. A BBC microbit is a pocket-sized computer. It is computer because it has a processor. Είναι υπολογιστής, έχει μικροεπεξεργαστή πάνω του. Εντάξει. That shows you how software and hardware work together. Hardware. And software will have here another program, make code on internet. So it has a LED display, buttons, sensors, and many features that you can program and interact with physically. Εντάξει, έχει πολλούς αισθητήρες, θα τους δούμε εδώ. Έχει αισθητήρες επάνω του. Μπορούμε να βάλουμε και εξωτερικούς αισθητήρες. Internal and external sensors. Yes, όπως εχθές. Λοιπόν, this is the front face and back. Okay. We'll see microbit in that way if we want to see something on the ledge. How can we program a microbit? Πώς μπορούμε να το προγραμματίσουμε? Three programming environments. Microsoft Make Code, that we'll use it today. Python, if you know, and Scratch. Okay. Now, let's begin. We'll go on internet, and please, you go on this make code. Okay. This is the environment. It's a Scratch-like environment. So, if you want to connect on make code, you can do it. And we'll have your programs after that. But you can have your programs and without have a connect, without logging it. Okay. Λοιπόν, when? A new project. Ωραία. Give your project name. One. A heart blinking. Ναι, εγώ τα έχω. Έχω link. Well, we'll create a program and we'll have a heart flashing, the simplest program we can do on microbit. So, forever, basic. Okay. So, a heart. Okay. Now, we'll see our heart on microbit. So, connect your wire on your PC. Is it okay? Να βάλουμε το καλώδιο. Basic show icon. Okay. Connect your... συνδέστε το στο...
to the laptop.
So, save here. Save. Save and OK. Close that. We don't need. And downloads, στα στοιχεία λήψης, downloads. It has to be here. Is that here? Okay. Right click, copy, αντιγραφή. And do you have microbit here? We click on microbit. Κλικάρουμε το microbit. And here, δεξί click, right click, paste, επικόλληση. Το αρχείο που αποθηκεύσαμε την καρδούλα. Copy, paste. We'll have a heart, but we want to blink like that. So lens, it's empty lens. Pause. 200 milliseconds. And again, the heart. So let's. Can you see it? Okay. Well, heart, empty lens, pause, heart, empty lens, and pause. Do you know how to add or delete? No. So. 200 milliseconds. Flash. Can we do the same procedure again? Save, copy, paste. Save, Αποθήκευση. Okay. Downloads. Στις λήψεις. We'll find it. Right click, δεξί κλικ, αντιγραφή, copy. We find microbit. Δεξί κλικ, right click, paste. Εντάξει. And here we have a simulation. That is very useful. If you want to see if your program is right. Is it that we want? Yes. Okay. It's okay? That's it. The simplest one. Next program. We go on microbit here. New project. Άλλο, next. Well, now, suppose we have lost our dice in a board game. What do we do? We use microbit to give us dice values. When button alpha. Well, here we have button alpha. It is a sensor, not touch, but push sensor. Button alpha, button beta. You can push them together or not, but and together also. So, when button alpha and when button A and button B are pressed at the same time, two integer random values appear from 1 to 6, like dices. Να εμφανίζονται από το 1 στο 6 σαν τα ζάρια. Αυτό, τυχαία κάθε φορά. Corresponding to the values that our dice would show. Okay? Well, give your project name to dice, create, and we begin. Programming. Now, input. On button alpha pressed. So we don't need this recycle bin. Recycle bin. Recycle. Αχ, πώς λέγεται η εντολή στα αγγλικά τώρα? Η εντολή στα αγγλικά? Command. Okay. Well, what do we have here? Button alpha, A, B, or together? Together. Okay. So, basic. Show number. We don't say so 1, 2, 3, but a random number every time. So, we go math. Just a minute. Pick random. And we have to choose numbers 1, 2, 2, 6. Ah, you listened. Okay. Is that okay? No. All right. I don't want the numbers be confused on LEDs, so I'll put a blank on a blank LED between two numbers. Ανάμεσα στο 1 και στο 6 θέλω ένα άδειο LED, ένα empty LED, γιατί δεν θέλω να μπερδεύονται 1, 6, μπορεί να πηγαίνουν μαζί. So, basic, blank LEDs, and again, but I want to be quick. Right-click on show number. Right-click, duplicate, δηλαδή we have it in a quick way, and right-click, duplicate, το διπλοπατάω, το δεξί κλικ, και το έχω. Do you have the numbers? Yeah. A and B together? Yeah. Is that correct? Yes, it works. It works. Κάτσε να δω. 4. 5, 4, yes. If in the case we have 4 and 4, if we didn't have put here show LEDs, we would not see 2 4s. 2, 4. Only one. Well, do you want me to ask something? Next. Well, sensor, you saw yesterday, is a device that detects a physical quantity and produces a measurable output from it. Λοιπόν, οι αισθητήρες παίρνουν δεδομένα, data, sensors get data from environment, and we can use them on microbit, on our program. Yesterday, we used water level sensor. Here, we have many sensors, built-in sensors. Ενσωματωμένοι αισθητήρες εδώ. Well, LEDs. We can show light on them, okay, but they can accept light from environment. I will do a program about this. Pins here. Pins, ακίδες. Τις λέμε pins, τα λέμε κιόλας. Έτσι. Okay. Touch logo. Touch. Here. This is a touch sensor. Δεν του το είχαμε. Έχει μικρόφωνο, microphone. So we'll do a program about microphone. We can see where is the loudest place on that room. So, processor and temperature sensor. This is very useful. Compass, πηξίδα, έτσι, θερμοκρασία, πηξίδα έχει, and accelerometer, επιταχυνσιόμετρο. We'll do it. It can detect this movement. Okay, yes. And when we run and we measure our steps, this is. When you have your phone and you to use them, so it has a sensor. Okay. All right. Next, play music. The project scenario, the microbit plays music forever if the light level is greater than one value, for example, 100, it plays a series of notes, otherwise plays another series of notes. So simple. Well, new project for microbit plays music and create. Microbit, okay? New project for music. Three was about sensors. Only theory. What did I say? Music. Okay. Okay. Forever. We don't need on start. Well, now, logic. Logic. If, then, else. And put it there. If, then, else. So this is the most important command on programming, the most important. If it rains, I'll get an umbrella. Else, I stay home. I stay home. Okay. It is snowing. Do I get an umbrella? No. No. Okay? It's important, very important. Well, play music according to light level. So, input, light level. Light. We want to activate light sensor. These LEDs. Okay. So, if light level is greater than 100, what did I say? For logic. Be careful, this command, not that. This command is used for letters. This is used for numbers, and we put it in there. Okay? I listen, click, click, click. If light level is greater than μεγαλύτερο, αν ο αισθητήρας φωτός δηλαδή μου δίνει μια τιμή μεγαλύτερη από 100, we'll see it. Can you see simulator? You can drag this simulator. The value of light level is 0 to 255. Okay? Well, play music. Some notes. You can choose anything you want. If you want a classroom right now, it will be noisy. Again. Another. Do, mi, sol, δεν ξέρω. All right. So, because I want to be fast, check, 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 right click, duplicate, anything you want, okay. Can you see simulator? So, the light level is larger than 100. Can you see it? It's changed. Yes? Do you want to save and load? Let's do it. We can stop by clicking on that. Καλά είναι. Ωραία. Save. Okay. Ellipses, downloads, music, αντιγραφή, copy, microbit, paste. Επικόλληση. Φόρτωσε. Ακούγεται. Εμένα κάνει... Δεν γιατί. Light sensor. Light sensor. Sorry. If you want to see the difference, you can put your hand over the ledge. It must change. If we want to be sure that what is our light level, okay, we can do this. Basic. Oh. Basic and show number. So what? I could. So, forever show number, and I'll put light level in that command. Light level. Έγινε. Light level. Can you see on simulator what will happen? But you must save and load again. Do it, please. You'll see the light level you are where your microbit is right now, and so you expect the right commands and the right music. Okay. Well, καλά είναι. If we want to restart the program, it has a button here. Restart. Hello? All right. Well, the next. Are you okay? Microbit? I can't. Okay. Λοιπόν. Πάμε λίγο. Temperature sensor. And I have this for changing temperature. Okay? All right. So, what will have? A new project. No.
When does it stop?
Βγες και ξαναμπες, δεν έλεγε Bill Gates. Turn off. Και εγώ το βγάλα. I can't. Λοιπόν, microbit displays the temperature. So, the scenario, the microbit displays the temperature of environment. Forever, the microbit displays the temperature every 2 seconds, and some LEDs light up accordingly. So, a new project, 5. Create. Ανάλογα με τη θερμοκρασία θα έχουμε διαφορετικά LED. Εντάξει. Forever. Basic. Show number. Βγάλτε το. Microbit keeps the program in it. And if we turn off microbit, okay, the former program is in it. Until a new program is loaded in it. Okay, in, on. Λοιπόν, show number. Input. Temperature. Θερμοκρασία. Τσακ. Σύγκριτης. Λοιπόν, something simple.
The new program is 5.
5. Temperature. Θερμοκρασία. What time is it? We're okay. Until now, we have only sensors. And actuators only LEDs. So number, logic. Are you okay? Are you okay with this structure? Okay. Oh, well, something simple. If this temperature is larger than... Τι θερμοκρασία έχουμε τώρα? Γύρω στους 20. Ναι. Ωραία. Οκ, να βάλουμε... Να το ανεβάζω εδώ με το... Στους 25 με πάει, ξέρω... Ωραία, και 30. 30. Πολύ. Okay, 25. Because we want to see the difference. Τι έχω... Γι' αυτό. Γι' αυτό. Δεν έχω μπαλαντέζα. Α, θα βγάλω τον υπολογιστή. Το ρεύμα του υπολογιστή και θα έχω την μπαλαντέζα. Εντάξει. Ωραία. Λοιπόν. Basic. I wanted to show you that. You can change the shape of the head, and I choose something. Everything, anything you want. Okay. We can do it. Save. Do you want it?
We already did it with the hand. Now it's 28, 27, and it's check.
But
we were like this.
Ah,
so,
with your hands.
Yeah.
Okay. Okay. Ah, you're a genius here. Το αλλάξανε με την ανάσα τους, με το χέρι. Δώσαν τη ζεστασιά. Θέλετε να το δείτε? If it's larger than 35. Έλα. Yes. 41. Το ζεστάναμε πολύ. Okay. Yes. Now, I want to see you I want us to see some graph. Depending on temperature, we'll have LEDs turn on. Ανάλογα με τη θερμοκρασία θα έχουμε τα blinks, τα LEDs να ανάβουν. Goes up. Okay. Now, on that.
Is there any chance to change the color of the LEDs?
It should
LED in blue or green, or is it always red? The color is always red.
Red.
Can we make
Red.
a command that it gets blue or yellow or something?
No.
Always red.
No, only red. Well, we'll change this program and we go on math. Load bar. No, just a minute. LED. LED, not math, LED. Plot bar graph. Every 100 milliseconds. So, we can see it on a simulator. If our temperature is 0, we have one LED turns on. If our temperature is the largest, all LEDs are turned on. So, duplicate. How much we want the largest temperature? 50. Or 40. Can you see it on a simulator? I can, okay, put an empty show LED. We'll see it on a simulator only. So, forever, we have the temperature, and depending on the temperature, some LEDs turn on. On LED. Sorry, here. On LED, not on math, on LED.
We found it.
Ναι, ωραία. Γιατί το ψάχνα και εγώ στο math. Just a minute. 200 milliseconds. And can you see it? On simulator, the temperature is 21. It's okay? And the half of LEDs are turned on because we have the half temperature from 0 to 40. Έχουμε τη μισή θερμοκρασία από το 0 έως τα 40, που είναι το 21, περίπου 20, εντάξει. Οπότε είναι ανοιχτά τα μισά LEDs. Το καταλαβαίνουμε. Προσέξτε. Πηγαίνετε εδώ, go on simulator and look at it. Can you see it? So, not to, 1 second. We see, βάλτε 1 second. 1 second. Okay, end. Για να το δείτε σταθερό. Το κάνετε? Όχι. If my temperature is 0, μείον 5. Όσο ανεβάζω τη θερμοκρασία, έχω και περισσότερα LEDs ανοιχτά. As the temperature is bigger, I have more LEDs turn on. Το είδατε? Εντάξει, το είδατε? Α, το βλέπετε και εδώ. You are fast. Το είδατε, εντάξει, είστε? Α, okay. So, next. Are you tired? Yeah. Oh, why? No. We continue. Microbit. New project. Something to be... We'll use accelerometer for you, because you are tired. Επειδή είστε κουρασμένοι. Κάντε κάτι... Λοιπόν, variable. Variable is something very, very important on programming. If we want to know how many steps we have until now, where my step is are put on, where, πού έχω τα βήματά μου τοποθετημένα, για να μου τα δείξει in order to microbit show me the steps, για να μου δείξει το microbit τα βήματα. Κάπου πρέπει να είναι. Αυτό το κάπου είναι οι μεταβλητές. Variables. An abstract storage location. This is important. The variable has a name, but το περιεχόμενο context is, it changes all the time. During the execution of the program does not change the name, but changes the context, the values it receives either within the program itself or having already acted externally. Where can we use variables? How could the program change if we wanted the board to show us how many times the head flashed? We don't know. We measure a day's temperatures within the microbit using the temperature sensor. We measure the ambient temperature every hour. And in the end, we want the microbit to show us the average temperature of the day. Let's say we use microbit to count out our steps that I saw. So, how many times we moved the microbit? This. Now, scenario. On start, the numbers of moves variable is 0. On shake, a shape appears on the ledge, and the value of the variable increases by 1. Tuck, 1, tuck, 2, tuck, 3, and so on. Okay, forever, if we press the button A of the microbit, the number of moves is displayed. Or, next, we are here, 6, shake. Shake it, baby, shake. Do you know the song? Well, basic. No, just a minute. On sec. I want to have an icon on Let's also, so basic. So you can your own shape, whatever you want, no? And instead of that, we have clear screen. I could put show LEDs, but there is also clear screen. So I have to create the variable. So variables, make a variable, number of secs, of moves, Okay. This is mine, okay? We have created the variable, so change number of moves by 1. The very important thing here is what is the first number of moves? 0. If we don't define that, it will not be correct. On start, variables, is it okay until now? On start, number of moves is 0. On sec, change by 1. So, on start is 0. Έτσι. Είναι 0. Κουνάω. 0 και 1, 1. 0 plus 1, 1. 1 plus 1, 2. 2 plus 1, 3, and so on. Εντάξει. So, we have to have the first number inside variable. Forever, if, without else, only if we press the A button, did you understand it? It's the first time that we did it. So, copy and it's okay.
It's next to each other, it's not like before.
Sorry?
Why can you put it next to each other now? Before we did this text.
No. We can have some blocks separate. Χωριστά. On start, forever, and on sec. It works. Can you see it? We can do it. Ενωμένο, όχι, δεν χρειάζεται. United, no. So, save. Δεν βλέπω τα microprint να κουνιούνται τρελά. Έγινε. Κουνήστε τα πολλές φορές. Και Μπουτόν α. Ίσως. Α, πάλι εγώ το είχα βγάλει. Είσαστε εντάξει? Well, microphone. Είμαστε εντάξει από το προηγούμενο? Are you okay? Okay. Εντάξει, κουνάτε, ένα. Υπάρχει και η καθυστέρηση της οθόνης γι' αυτό. Δηλαδή, ο χρόνος που έχουμε για το σχήμα, μπορεί να κουνάς το σύνορα. Α, έχει διάφορες κινήσεις. Ναι, γιατί στο χρόνο αυτό δείχνει και την εικόνα που βάλαμε. Εγώ την έβαλα για να βλέπετε ότι έχει γίνει κίνηση όντως. Ναι. Ωραία. Microphone. The project scenario, forever, if we press the logo of microbit, touch sensor, we said about it, the sound level that the microbit currently receives is displayed. If the sound level is higher than 50, then a shape appears on the lens, else a different shape appears. Okay? Note, we'll use variable sound this moment. So, we begin. Microbit, new project, 7, microphone, well, forever, if only if logo is pressed. I'll try to have different commands to see all the sensors. Logo, where is? Ah, down. So, when this is logo, okay. When we touch it, I want to say us on the screen how much is the sound level. So, basic, variables, make a variable here, sound this moment. Okay. Ωραία. Where the program finds the context of the variable? On microphone. Input, variables, set, input, sound level. Sorry. Το πέρασα. Okay. Thank you. Now, we have the variable, sound this moment, the name, sound this moment. And what we put in that sound level. Where can microbit get the sound level? From microphone. Microphone is a sound sensor. Okay, so is okay until now, and when το βλέπουμε και ας βάλουμε μια καθυστέρηση, delay. Because we have some time, as we saw, where the numbers are coming on LEDs. That's why. And clear screen. Let's see scenario again. If the sound level is higher than 50, then shape appears on the LED, else a different shape appears. Do you want to do it by yourself? Yes, you want. Inside, okay. It's, okay. Βοηθώ. Here, it's an if inside another if. Ωραία. It's a nested if, that call it nested if. You must touch the logo. Does it work?
If it's noisy, it's sad. If not, happy.
Happy. Εντάξει, πατάτε το logo για να δουλέψει. Well, we're waiting a little bit. But we can touch, you have to touch. Το φορτώσατε? Yes, the...
To make...
Yeah, okay, yes. Here, we have pins. Ακίδες το λέμε στα ελληνικά. At the bottom end of the BBC microbit are 25 cold stripes called pins. These pins allow you to create circuits, connect external things, like buzzers, motors, headphones, field touch, and make your own fun projects. You'll see now, by expanding the capabilities of microbit. Be careful, we never connect ground. Do you see that? Ground, γείωση στα ελληνικά, είναι γείωση, and τάση, 3 volts. We never touch them together. One hand on ground and one hand on 3 volts. No, it will be destroyed. Okay. Well, let's see that. The project scenario. Forever, if P1 is pressed, then the microbit plays a tone. If P2 is pressed, the microbit plays another tone. Okay. I want to show you this. How can we play music with fruits? Πώς θα παίξουμε μουσική με φρούτα? Kids love it. I get some fruits in the classroom. So we have a fruit salad. And we have for each microbit some fruits. One fruit is on ground, and other fruits are on P0, P1, P2. So we have one hand on ground and one hand on banana. Ding. Ground, lemon. Bang. Bing, bang, bing, bang, bing, bang. Do you understand? It's very funny. We can do it, and with foley, okay, it's easy, and with figures. We are a secret, and but our figures must be wet. No, now we'll do it. It's a simple program, but it's interesting to introduce you on pins. So let's see this. Forever, if P1 pressed, then microbit plays a tone. If P2 pressed, another tone. Okay. Go to microbit. Microbit, new project, 8, pins, create, something simple, forever, if input, we have, sorry, this. It's better if PMI then is pressed, and we'll have a music. Please put one note, because I want to have a quick change of notes. Okay? And because I am lazy, duplicate all this. Tack. Be careful, we have to change pin, pinena, and something else. Well, that's it. Save it, copy it. Let's go. If it doesn't work, I have a foley paper. You can do it right now with your fingers, or you're good. Okay. Bravo. If we have fruits, we use them. Okay. One cable on ground and other cables on P1, P2. Okay. We can have one child on ground and other child on P1, and between one child and the other, their hand together, because we wanted to make a circuit. Microbit, ground, child, child, P1, microbit. We have a circuit. Servo motor, actuator. Until now, we have as actuator the ledge. Now, we'll have servo motor. This is a motor. Find it, and find and the shield. This. Two, shield and... όχι πράσινο, αυτό. Έχει σημασία, είναι διαφορετικά. Orange motor. Σε κοιτάω και... Ναι, this. Ναι. Okay. Αυτά.
This one, like the big one?
Yes, this. So, we have microbit, the wire on PC, the board, a wire, this wire, not another one, this, on P0. You can put it on P0, but be careful. This is a coffee, brown coffee. Brown, yes, a brown wire on ground. G, ground, vena, here. Ground.
Okay.
Ground.
On the first one.
First. Ground. Στοιχείωση. Ναι, okay. Στοιχείωση. Κάτσε να δω. Ναι. This is a servo motor. How does it work? Stop on 90. Speed degrees 0, degrees 180. So, on 90, it does the move. 90, stop. 0, okay? And 180, okay? Okay. You can think about bridge yesterday. So, and then I had a motor. It was not a servo motor, but I used the direction. This way, bridge goes up, yes, and that way goes down. Okay, so now on microbit. The scenario, forever, the motor turns one way for 1 second, stops for 1 second, turns on the other way for 1 second, and stops again. In order to see that this working, just a minute, because you cannot see the axis. You can use this on, is compatible to Lego. Very important. On axis, στον άξονα πάνω. Βάλτε το λίγο εσείς, εδώ έτσι, το χεράκι σας. Για να το δείτε, να παίζει καλά δηλαδή. Και να μπορείτε να παρατηρήσετε. Another project, another program, microbit, new project, 9, motor, create. And now we'll not have any sensors, only actuator, forever. where is the commands of servo? They are not here. We must have to go to, we must go to extensions. There are some extensions here. We pick up servo. And now we have some commands about servos. Do you have it? Okay, servo. That's it. Very simple. If you know that we can find it there, okay. So, let's begin. Jack. 90. Pause. 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 1 second. And pause. We can see how can change the degrees. We can drag on 0. Okay, so right click, duplicate. Be careful, we are on P0. So you have to motor on P0. If you have put it on P1, it doesn't work. Or if you have it on P1, αν το έχετε στο P1, θα διαλέξετε και από εδώ P1. You choose P1, okay? So, go. Κάνω λίγο γρήγορα. Well, what did we say? 0, yes. 90. 180. I follow the scenario. Ζεστάθηκα τώρα. Λοιπόν, 0, 90, 180, σύμφωνα με το σενάριο, κοιτάω. Οκ, εντάξει. Ωραία. You can copy, that's it. Save. This servo motor is compatible to Lego. So it is very useful. Okay. So, next. The strange thing here is that 90 is not the degree of the angle. It stops. On 90, it stops. Okay. Δεν γυρίζει 90 μοίρες. Δεν γυρίζει 90 μοίρες. Γυρίζει για 1 δευτερόλεπτο. Προς τα πού? Προς μια κατεύθυνση. 0 shows one direction and 180 shows the opposite direction. Εντάξει. And το 0 δείχνει τη μια κατεύθυνση, το 180 δείχνει την άλλη κατεύθυνση. This or that. 90 shows motor stops. Ωραία. Κλείνω. Next. as yesterday, a humidity sensor. So little. So, quickly. Okay. We'll have, please find, καθίστε τώρα να σας πω τι θα βρείτε. One sensor, κοίτα τώρα. This sensor, this. Okay. Humidity sensor. Now, we could put on soil, but we do it only with our fingers. So, soil scenario. Forever, the microbit displays soil moisture values. I can say moisture of our hand. Okay. If the humidity value is less than 500, then the motor is activated. Otherwise, the motor is inactive. Motor and this. Motor on P0, 0, and with cable, external sensor, στο P1, on P1. Be careful. The black one on ground, yes, στοιχείο C. Θέλω να σας φάω το διάλειμμα τώρα. Microbit. Vamos. New project. 10. Moisture. And servo. Create. Oh, well, now we'll have a variable, make a variable, moisture. Okay. Λοιπόν, we'll have the variable. Okay. Set moisture 2. Where do we have put analog sensor? Advanced. Pins. Όλο και έχει. Pins. This is, we have something important, not digital, but analog read. Analog pin. Where do we have it? On pin 1? P1. Okay, because on P0 we have the motor. Εντάξει. Okay. Ωραία. Ας δούμε την υγρασία. Λοιπόν. Basic. So, I want to tell me how the moisture is. So, variables. Moisture. Do we understand it? Okay. Pins, sensor, gets the value of the environment, and puts the value on variable. So number, okay, and if then else, something zip, this, κάνω duplicate εδώ, if moisture is less than, έχω βάλει μια τιμή 500, 500. We'll see about that because we'll do it with our hands. One direction, okay. Και θα πηγαίνει, αλλιώς θα πηγαίνει από την άλλη. So simple. I'm not sure about 500. We'll see. Okay. We'll see the mature when we have the microbit. Save it and copy it. Do I have a servo PIMI then? Yes. Thank you very much.
Στα δικά μας. Ποιο παντρεύουμε.
Έλα,